Thank you for joining us today on Webinar Wednesday, on our weekly Wednesday sessions where we run through some information about some of the products that we offer. This is going to be a mix between kind of a demonstration of some of the software and also kind of tips and tricks. And today we're going to focus on CAMWorks and its integration with SOLIDWORKS. So I'm Daniel Lyon. I'm an applications engineer for Hawkridge out of our Richmond, British Columbia office. And just a little bit about us in case you're not familiar with Hawkridge and who we are. We're the largest SOLIDWORKS reseller in the world. We've been doing this since about 97, I believe. So right around when SOLIDWORKS started. So we've got a lot of experience in getting customers up to speed using SOLIDWORKS. We offer training courses in SOLIDWORKS and CAMWorks, either one-day classes all the way up to four-day classes, 5-day classes, and custom classes if needs be. We also offer night school, so every quarter we offer a night school which is free to attend. So those are always a fun one where you get out to meet the users in the local area. And we have a variety of different methods of getting tech support. You can email in, you can call in, you can even live chat with someone on the website there. We can log into your screen using GoToMeeting, like your GoToWebinar today. I can flip this over to your screen and we can figure out exactly what you're doing and get you going as soon as possible. As far as the tech support team goes, we have one of the largest teams in North America, over 65 certified engineers. And basically you're getting on one of those engineers on the phone 95% of the time within 30 seconds of calling in. So that's one of the biggest, strongest points that I like to promote. Basically, you're getting a live person. You're not having to wait for anyone to call you back or anything like that. So we also offer a number of services. So if you want to check out some of those, we can basically do custom programming for you, build custom tools for you, run some simulation information, and pass it back to you, or do some mentoring and that sort of stuff. So. But check out the website. There's lots of good information on there. And today we're going to focus on mainly CAMWorks, but looking at kind of SOLIDWORKS and how it can integrate inside of SOLIDWORKS. Obviously, the SOLIDWORKS is your mechanical design package, as you can see down the lower left here. But SOLIDWORKS offers a number of different other products, including stuff for technical communication, things like assembly instructions, websites so people can click on content and kind of get part numbers and bill of materials, all interactive type of stuff. Simulation for stress analysis or flow analysis, data management to store all that data in a vault, check it in, check it out, make sure everyone's using the latest versions. And electrical design. There are a few others that are on the way. This is a little bit of an older image, but they keep expanding their range into different areas. CAMWorks is a partner product. Basically, the company behind it is a company called Geometric, which is a global company. One of their main products that they built is actually e-drawings. So anytime you see e-drawings, the 3D viewer for SOLIDWORKS files or for other CAD files, Geometric actually built that technology and then licensed it out. They also build things like DFM Pro for design for manufacture. There's a DFM Express in every SOLIDWORKS version in the Evaluate tab, which is a pretty handy tool to analyze if your model can actually be manufactured. They also do nesting technology for things like routers, plasma cutters, water jets, all that sort of stuff. And they actually developed the feature recognition technology that you see in CAMWorks, but also the one that SOLIDWORKS uses to try and build history from using FeatureWorks tools in SOLIDWORKS Professional. So those guys are a big company doing a lot of different software development. But CAMWorks is their CAM package, basically. So it's been around since about 97. It's nothing new. It's got a long system of development being going on it and constantly updating with the new technology that the machines offer these days. So we do all the way from 2.5 axis up to full 5 axis on the mills. Lathes, we do all the multitasker or the live tooling lathes or the mill turns, whatever you want to call them. as well, all the way up to 8 axis. So if you've got a front turret, a rear turret, main spindle, sub-spindle, or B-axis head that kicks over, all that sort of stuff, we can program those, as well as wire EDM support for 2 and 4 axis wire EDM. So if you've got tapers and stuff like that, we do offer that to be able to program. And one of the greatest benefits of CAMWorks is the basically integration inside of SOLIDWORks. You've got pretty much top-level CAD tool that's pretty much industry standard, and you're programming your machines basically right inside of that same interface. So you can actually leverage a lot of the information that's already been built into the model, the sketches, the data, and things like that, and then extract that information for you actually setting up your programs. But you don't necessarily need that data if you're a job shop and you're working off imported files such as Parasolar files or step files or IGES files or those kind of things. You can actually bring that information in too, and the feature recognition will actually look at it and start extracting the data from the model as well. And the other beautiful thing is if you do make a change to the model, I know people go through ECOs and things like that, change requests in their systems and their companies. You've got a revision change. Okay, well, how does that affect the program? Basically, in CAMWorks, there's no having to export anything. We're working right inside the SOLIDWORks model. The toolpath lives in the model. If the engineer goes and changes the model, he won't see CAM because he doesn't have the add-in loaded. But as soon as the programmer brings it back up, you'll see the toolpath will actually prompt you to update, and you'll see some of that later on. And really what we're trying to do with these different solutions with the SOLIDWORks and CAMWorks and a few of the other products that we offer is basically try and streamline this product development process. So in a very archaic kind of system, you're kind of in a sequential process from design. You do some simulation on that design to make sure it's going to work. Maybe then you validate that simulation data, do some prototyping, some 3D printing maybe. And then you might go through a few revisions, loops back, you review the information and go stuff it back in the system at the beginning again, and then finally get to the manufacturing at the end. Now, in some systems and some companies, that process could be a case of, well, I'm using, say, SOLIDWORks for design, I'm maybe using ANSYS or something for simulation, I'm doing some prototyping manually, and then maybe manufacturing is in like a Mastercam type thing. By using each of those separate products, you're creating a break in the system, so you have to re-export files out, reset up the data, and all that sort of stuff. So you end up having to actually rework a lot of the stuff. And also you create this system where your design and your manufacturer are opposite ends of the spectrum. They're basically, they're not really communicating to each other. So if the designers go and start designing something that can't be made, which I know happens, I would say, more than we would like, it often ends up being exported to a separate manufacturer, external manufacturer for outsourcing, basically, because you couldn't produce it in-house. Whereas if you actually streamline the process, you actually have more communication between everyone. The technical documentation guys can start producing their manuals and stuff at the same time as maybe you are doing some prototyping and validation of some simulation data. The programmers can get started and have their input on the models and say, hey, we can make this in-house, or it maybe needs to be outsourced. And everything's kind of streamlined, everything's concurrent, so everyone's communicating more, but also the time frame shortened, so you're actually getting better collaboration between all of your teams. And by using one software, you're not having to pay separate license fees, you're not having to go to separate vendors to get support. You're coming to one company and then basically getting your full solution. And by doing that, you're actually getting better designs and reducing the part costs and keeping more manufacturing in-house, because you don't have to realize at the last minute, hey, we can't produce this because we don't have the tooling, or we don't have the fixtures, or we don't have something for it. So with that, let's take a look at SOLIDWORks and CAMWorks together. And today we're going to use this kind of outboard motor here to give you an example of basically how we can go about doing some programming, maybe making some changes, looking at some of the tools inside of SOLIDWORks to see the integration. And in here we've got some detail in here. We've got this shaft assembly down here with the reverse and forward gears here, some bearings. And we're going to take a look at programming the shaft to start with here. So we've got this prop shaft that we're going to work with. It's got some threads on it, some splines, some different turn profiles here, a flat spot with a slot in there and things like that, some holes in the end. So essentially we're opening up the SOLIDWORks model. You can see the SOLIDWORks history on the left. It doesn't need to have this history to use any of the feature recognition tools, but basically it's nice because we're working on the SOLIDWORks model. We don't have to export things if you are using SOLIDWORks for your design. So CAMWorks is basically an add-in. You go and check on the options over here whenever you need it. It loads up a series of toolbars across the top and an extra few sets of tabs over on the left there. So you've got your CW tab, which is going to list things like geometry, features, pockets, holes, bosses, that type of thing, surfaces for any 3-axis, 4-axis, 5-axis stuff. The operation tree here is going to list things like rough and finish, or face, rough, face, finish, OD profile, turn, groove, that kind of stuff. And then you've got a tool tab over here. And as far as switching this between different machines, we basically just go up into the machine area over here, and this is where we can switch it between different types of machines. We're doing EDM, or if we're doing the live tooling lathes. If we're doing a regular lathe or a mill, for instance, we can switch them out down here. And these can all be named exactly how you want them to be matched to the shop floor, basically. As far as your tool cribs go, this is where you can actually build your tool cribs and match them exactly how you guys have them in the shop, whether the tools live in that machine, and you maybe change a few of the higher tool numbers out. You can build it up that way, or you can just build, say, one tool crib and have it automatically just be used for all the different machines in there, and you just switch them out whenever you need to. As far as post goes, this is where we can go select the post processor. I'm just going to grab a turn post here, one of the tutorial ones. And we can go and choose some of the coordinate systems. Now this has got some mill features on it. We're going to use as an example in this case of a separate lathe and a separate mill. So we got like maybe a 4-axis mill, and we're going to go maybe keyway cut the splines. And then we're going to do the lathe programming on the lathe. And I want to show you how we deal with those type of things. So in this case, we've got a lathe coordinate system right on the end of my pod over here, and I can go and define where my chuck sits and things like that. So stock-wise, we can go in and say maybe bump up the stock a little bit, so we've got some material on the outside. Because it's a lathe, it's now cylindrical stock as opposed to kind of flat stock for a mill, for instance. We can add a little material to the end, and then maybe just kind of a little bit of material down at the back there just so we can clamp it in the chuck. Now this is where we can use some of the feature recognition. So I can hit this extract machinable features, and it's going to scan the model in this case for turn features, things like OD features, ID features, faces, cutoffs, that sort of thing. If it was a mill, it'd be looking at pockets, holes, bosses, slots, all that sort of stuff, basically. But basically, it's going to look through the model, extract some of the geometry for me, and put in a setup for me. So you can see here, it put in the turn setup, and then it's found these kind of face features. So you can click on any of them, and you can see that it's facing off the end here. It's looking at the OD profile here. It's skipping over the groove because that's being done separately here. So we've got these different profiles. It found the ID feature here, the countersink here to put it between maybe a tailstop just to support it. Obviously, this is quite a long pot. And then there is a hole on the other end as well. So when we're maybe chucking it in the other side, maybe we're doing some grinding or something for some bearings, we've got another setup on the other side, and it recognizes that basically you need to throw it in this side, rechuck it. You can also, if you wanted to, you could treat it as a sub-spindle operation. We do support main spindle and sub-spindle operations and transfers between them. But the feature recognition is looking at the model, The other thing, which is nice about CAMWorks, the feature recognition saves time by letting it basically define the features in the geometry for you. But when it's doing that, it's also looking at strategies. So it's basically like a library of toolpaths, a library of how you want to go through and machine those different types of features. Now, CAMWorks comes with a library preloaded. There's stuff in there. It might not be exactly how you want to go and cut it, but it gets you kind of started. But you can always save back to it. So if I want to program this part, it's just the case of going, hey, we'll use that database. It goes in and does a lookup, and it switches over here for us. It generates all of these operations with the tooling for me, and then if I hit generate toolpath, it will go through and it'll turn everything from pink to black to say, okay, I managed to generate something. Say, for instance, maybe the tool was in the wrong orientation, or it couldn't fit in a particular hole, for instance. Then what you would see is something like this. It would actually stay pink here. If I didn't add any material on the end here, it would assume that, hey, there's nothing left to machine, so we wouldn't end up doing a facing operation here, and that's what it would look like. But it basically programmed that file in really 3 clicks. You can see in the simulation, if we just slow it down a little bit here, it's going and grabbing the tools, going and putting the code for us, running the profile down the outside there, coming back and finishing it. And this is all color-coded. There's a groove here. There's just roughing out the groove. That's why it's doing kind of like a peck cycle all the way along there. And then it's on the end profile as well here. So, and we can compare exactly, see what's being left machined. Obviously, it's not done the splines in this case. But it's got all the grooving operations here. There's maybe a little bit of material left here from maybe the tool angle, so we can maybe adjust that. But essentially, one thing it didn't do is the threads over here. So I kind of intentionally left that off here. Basically, what we can do for programming these threads is we can go and insert features. So this is how we would insert features manually. If you didn't want to use a feature recognition, if you want to just tell it which geometry you want to program, you choose the type of feature at the top, ID feature, groove, face, cutoff, OD feature. You choose the strategy. Okay, I'm going to thread this, and I'm just basically going to select the geometry over here. Click on the check. Now, as far as defining what thread it's going to generate, I just right-click and go into the parameters here. And this is where it accesses the library. It brings up a window from the database of different strategies and different settings already built in there. So this is a 7/8 thread here. So we can just go and select our 7/8, the UNC. And then all I have to do to program it is just to generate operation plan and generate toolpath here. And I've basically got some threading toolpath in there now. So if we just quickly simulate everything, you should see actually doing the threading now here as well. So obviously the chuck would be clamping probably a little further over on this end over here. We can obviously go and move that chuck to wherever we want it to. We can shift it around. We can tell it what diameter and things like that to clamp on. So we could go and actually tell it to clamp on certain diameters and shift the position of it to wherever we need it to be for that particular setup. The other thing that we can do, though, is say, for instance, we're simulating this toolpath. We've not done the keyways right now. What I'm going to do now is basically show you how you can work between lathes and mills if you've got some programmers on the lathes, some programmers on the mills, and maybe they don't know what the starting material looks like. Basically, what we can do, obviously, you can compare the toolpath over here and see what the actual program cuts versus what the finished part looks like. But obviously there's this chunk of material at the end that the cutoff basically took away. So we don't want that. We can go in and just basically get rid of that. And we can save this to an STL file, basically, to use as the input as the stock on the mill. So I'm just going to switch it to save out to the mill coordinate system. We'll leave it set to that same name here. And then as far as doing the milling side, obviously this is all for the lathe. Well, CAMWorks has configurations inside of here. So if I've got one part and it's got multiple different ops and different machines, I can do that and stage that using configurations, just like our SOLIDWORKS configurations are used for maybe creating different pieces of geometry. We can simplify models using these. We have CAMWorks configurations here to basically go and program different machinery. So basically in here, we go and set all the parameters up for the mill, go set the tools up, go and select which one we're going to program it on. In this case, if we're doing some indexing, we can go, maybe it's a 4-axis machine here. We use a coordinate system on the end over here. Go tell it some information about where it rotates and things like that. But then we can go and set that stock up and use that output from the lathe basically to input it as stock on the mill. So we know exactly where we can wrap it from, we know where we can wrap it to, we know what the shape of the toolpath is programmed so far, basically just creating a nicer looking understanding for the user of where's left to program. So now we can go in and maybe use some feature recognition on here. We can use that same feature recognition tool, but because it's now set to a mill, it's now going to go and grab pockets, holes, bosses, that type of thing. So it's going to look at the model here, recognize the geometry on the mill side, and this could all be done in one mill turn machine if we set that up. But I wanted to show you how basically we'll deal with these multiple machines. Countersink holes have maybe already been done on the lathe, so we can just get rid of some of this information that we don't need to do anymore. We've got an ob-round pocket which is being machined from this particular direction, but maybe we want to machine it from the same direction as this. There's obviously a through slot here. This is for the clutch dog to engage between the two gears. We want to move it to the opposite direction, so we don't want to be programming it from this direction. We can just simply drag it down to the setup over here that is being machined in that same slot on the top here. So now they're both part of the same group. And it found some other stuff over here. There's a little slot that it found there, so if we don't need that, we can just get rid of that sort of stuff. Again, use the database, go through, program the pod here. And this is basically a perfect example of using the feature recognition. And what it would do is if it can't fit the tool in that particular geometry. Now, it's trying to use a 1/4-inch tool right now. This is an 1/8-inch radius, so 1/4-inch total, but there's probably an allowance on that rough which says, hey, don't leave 10 thou on the walls. It's not generating because it won't let me generate, it won't let me go in and put the tool in that region because it can't fit the tool down there. So I know instantly that, hey, I might need to go in and switch the tool size out, and I can access a tool crib here and go and switch it to a particular tool that I want. Or I can just go in and say, hey, I want to use a 3/16 in here. We'll go in and say, okay, use a 3/16 for this here. Maybe go and change the tool comment down here as well, just on the fly here. And now I can go and generate a roughing pass here with the allowances that basically we've left on the side of the pod here, so the finishing pass can go and clear them away. As far as this other one goes, this irregular slot on the top, this one actually had a couple of different options here. It was defaulted to do a rough and a finish. So the first one would go and clear out the material. The second one would basically come and clean up any leftover if the tool couldn't fit in there. Obviously, there's no stock left, so it basically didn't generate it. So we could just get rid of that one and just use that first tool path. And then we've got this slot here. Now these edges here are open to the air. We don't want to sit there machining those. They should have been machined away by some of this stuff here anyway. So we can just maybe modify some of the parameters to go in and say remove those air segments. So this basically here is going to tell us to wrap it across rather than sit there machining and wasting feed time down these basically. So now we just go in across, clean up those sidewalls there as well. And we could also do the bottom as well. If we wanted to make sure that bottom was perfectly flat, we could check on the options and go through and basically enable the different options there. As far as things like the keyways and the splines go in here, we're going to keyway cut these. So I'm going to go in and put in another setup here just to go and program those over here. So this is how I go and basically tell it, hey, I want a new machining orientation. We can go in and say, okay, well, we'll use the front plane over here. We'll go in and look on where that front plane is sitting. So it's actually here. So we're going to go and cut this particular keyway right here. So basically I just tell it the type of geometry that I want to go and use. In this case, I'm going to use an open profile, basically something without a closed shape. So we just go and grab the geometry over here. So we don't need that face in there. So I'm just using this edge of the model to drive the toolpath. And basically I can set a depth. In this case, let's just go up to a vertex right here. And then I can also choose strategy. So I can define, okay, well, maybe I'm doing this quite regularly. I can save a strategy based on what I've done previously back to the database, and I've just done one here with a keyway cutter already programmed into it. So I can basically just hit generate, and it basically goes and programs that particular keyway for me. Same thing could be done on the other side over here as well. Basically repeated process, but so we're working on this one, I believe. So we've got that geometry here. We just want to go and define the depth and change that strategy as well here. And just use that database to go and generate the toolpath. Now that's only one of them. We don't have to spend all of our time going around and repeating that entire process to get the rest of the splines in here. Just like SOLIDWORks has your pattern tools over here, linear patterns, circular patterns, we can go and pattern these as well. So we can just right-click on the feature. Any operations that we use to program these, if there was multiple, like a rough, a finish, a drill, a center drill, an attack or something like that, we can use these patterns and everything would be taken across with it. We've got a few different types of the linear, circular. We can also use sketch to drive it. In this case, obviously, a circular pattern. We want there's 17 keyways in here, and then basically go and generate those. So pattern again repeated for this one here. Use the shaft here. We just want 17 of those, and then basically that's being repeated all the way around. The toolpath is going to update all the way around as well. But in this case, on the other end of the shaft, we've got this flat spot. Now, there is toolpath right here right now, but there doesn't have to be. One of the nice things about those pattern features is we can actually still specify instances to skip. So if I don't want these different options, these different areas, I know it's a regular pattern, I know there's a regular spacing of 17 around here, but if I don't want certain ones to generate, I can just use the instances to skip down here, and now that program no longer goes in and cuts those particular toolpaths. So we can simulate that entire process. You can see the stock comes through with all of the threads in here, going through, doing the keyway cuts here. And then we can just compare the model as well. So we're looking pretty good. Maybe there's a little bit of allowance here. The threads, because they weren't modeled initially, we're actually looking at it's saying it's gouged, but really it's just the threads being modeled there. So we've got our programs. Maybe we have also, say for instance, we're looking at some wire EDMs on that boat here. On the prop, there might be a wire EDM profile as well. That's basically engaging on these splines over here. So if we're working with these multiple pots, it's actually just behind here. We've got a brass coupling here for the splines. Maybe we're doing some EDM stuff on here as well. Again, we can go and specify material, the machine, the stock, and how we want it to program. In this case, because it is an EDM pot here, we can basically just use the feature recognition again, It's recognizing the splines for us around the inside, and also it would be cutting the outside profile, but I don't want to do that. We'll just turn it on the lathe. Use the database, go and generate the toolpath, and we've got some toolpath in here to go and cut that with our wire EDM. So you can see it's going to go in and feed in the wires, and we can obviously put in holes to feed it through and things like that, but that's our wire EDM stuff programmed as well. Now if we just save these, go back to say the prop shaft over here, what happens if then the designer says, oh, we made a mistake, or we need to bump up the revision on this here? Maybe it goes through a PDM workflow. If you've got your PDM system set up basically using the SOLIDWORKS PDM client for enterprise PDM, maybe you go through a different state. You can actually enable the options over here, check the file back in, maybe switch the state on it to put it through a different workflow loop, go through ECO, all that process and things like that. And then when it comes back to you, basically, so if we just make a change to this model here, in this case, I'm going to change the diameter of the spline reading here, since we just focused on a lot of those in the different options there. So if we maybe change it up to like an inch and an eighth here. So just simulating a change that the designer would make. Basically what we need to do is we need to go back to our toolpath and now have it update. So at this point in that broken system of here's a separate software package for the design side, here's the simulation, here's the rest of it, here's the manufacturing right at the end, you'd end up possibly having to export another file out to the machinist, and then he has to go and either reprogram that small section, or to make sure everything's up to date on the latest rev, you'd have to reprogram everything. Now, in this case, it's not the case. We just basically go over to our CAM tab. Basically, we click on one of the tabs over here, and it's going to recognize that the model's changed. So we do an update on the lathe side. It's going to update the toolpath in here, and basically update the profiles for that. And then we'll switch it over to the mill side, basically updating the keyway cuts. It's going to change the toolpath to stick it further out. So we'll just let it do its update here. And this is a slick process. It's a couple, maybe what, 10, 30 seconds maybe to go through and update that particular toolpath. But now that's been basically updated. The OD profile of this is updated to that new profile here. All of the toolpath's going to update. And now that's just a simple change, but there might be additional features in there. When it does that update, it would actually find additional features for you. So if someone added a groove over here, then it could go and find the groove and say, okay, you've got a groove feature now in here. Do you want to program that separately, or do you want to leave it as it was? As far as the mill side goes here, we'll just do a quick reload on the mill side as well. And we'll update that toolpath. So all we need to do is really just post the code using the post processor again, and basically away we go. So that's just updating the profiles here now. The keyways are now being basically, that's the ones on the other end here. The keyways have now been shifted out. Again, you can run through the simulation, check it out, make sure. Obviously, the STL file would need to be switched out as well to make sure you are cutting on the right size. In this case, you can see, because I've not updated the STL, it's not really cutting the model. But that's just showing you basically that the toolpath's just updated. So all I'd have to do is resimulate the turn toolpath again, save out the STL file, input it as a stock on the mill again, and then away we go. And as far as the EDM part goes, basically, this one isn't linked, but if we go in and change it, so if we go in and changing the size of it up, we can go through, change the model, quickly go back over, do a quick update. It's going to basically come up, and this is what it will do is, if the model has changed to a different size of feature or different type of geometry or something like that, it will say, do you want to link the two? So you can associate the two together, replace the two, and then basically you just need to go and generate the toolpath again, and now this is updated to the new size. So it's a pretty streamlined process to go through and update, and that's 3 separate programs. Maybe that would normally be maybe 3 separate files that you're having to manage as well, and then 3 sets of posted code as well on top of that. So, and the other nice thing is if you do save the toolpath here, it lives in the file, so you don't have any external data. The only external information that is saved is the posted code, and that could be linked to the files using the PDM system or something like that. Another file that I wanted to take a look at was the actual shroud for the engine cover here as well. So if we just go back this particular model and maybe look at doing kind of a mold for this top upper cover up here. I've actually just kind of got one in here that I put in. And this one started off basically as importing the file into a separate part file. Maybe engineering has this and wants to keep hold of all the design side of it, and they don't want any changes to be made to it, but you need to go and create a mold for it. Well, I just imported the file using insert part. It still keeps the link, so it's still up to date. It will still track changes as it goes through. But now I can start building a mold from it. So I just basically created a block here. Let's just go and hide that temporarily so you can see. I capped off the surface here at the end of this particular vent for the engine here. And then I used some of the great SOLIDWORks tools for creating a mold. Intersect was something they added, I think, in 2015 or 2014 maybe. Fantastic tool for going and basically taking those 3 pieces of geometry and creating this mold. And obviously we could scale it up if we're doing plastics and doing percent shrinkage and things like that. And then we're also, in this case, because we've got this vent over in here in the mold, we've got to create some sliding cores for this mold in here, because obviously I can't get down here and start machining underneath that lip there. So if we go on the other side over here, you obviously can't get your tool down here and start putting stuff in there. So we've got some sliding cores that we need to worry about. Well, all it was a simple case of drawing a sketch of the outside shape of this profile here and going and using my mold tools. So again, another tool inside of SOLIDWORks using the standard basic SOLIDWORks package, just using this core tool here, and it's going to take that profile and split it out to be a separate core. So now it's a separate body in this piece. Let me just bring this back over here. So now I can just hide that core piece out. And then we do the same again with the other core piece as well on the other side. So we can basically just hide those 2 core pieces out and maybe program those separately. I've got some coordinate systems and some other stuff in here, but I wanted to go and talk about maybe some 5-axis and so using some of the other SOLIDWORks tools inside of here as well. When you first look at a part, you don't always know exactly, hey, has it got draft on it? Has it got any undercuts in it? Because if I do have undercuts in it, maybe it's going to affect the way I program it. Maybe I can't use 3-axis anymore. I've got to go to 5-axis. In this case, it's a deep cavity, so I would have to probably go to 5-axis in here. So I can use some of the tools on that evaluate toolbar, the standard SOLIDWORks tools. And this is the great thing about having a CAD package, a really top-notch CAD package, right next to your CAM package. You can use all of the tools that the designer is using for going and saying, okay, let's look at the draft on the part. I want to see where there is any draft in here. Okay, I know I can see there's an undercut in this region here. If I hover over it here, it's slightly undercut in this region too. So if I set it to 0, basically you can see all of that region there is actually undercut. There's obviously a bit where the cores and stuff go as well. So I can use the draft analysis tools there. There's even actually one called undercut analysis as well, which will give you more information about the faces themselves. It will actually allow you to go and say hide the faces as well. So if there are any undercut faces here, you can basically hide the ones which don't have any undercut here, basically, and see where the ones that are a problem are at. So it's a really nice tool. and just using those tools to kind of get you some knowledge about the part in here. So I know that that's undercut. I know I have to go and tilt the tool away and go in here and maybe use a different approach to machining it. So as far as machining it goes, I just want to start looking at programming this. So we'll put in the setup here. There's no 2.5 axis feature, so we couldn't really use feature recognition here, but we can go in and tell it the surfaces to machine. So in this case, I'm just going to grab everything. We can still use our strategies in our database for 3, 4, 5 axis as well. Basically, in this case, I'm going to use a roughing, a 3-axis rough, and a constant step down on the Z. Let's just get rid of this. So we can go in and generate some toolpaths here. In this case, I just want to limit it to certain regions. I want to limit it to this region in the middle here. I don't want any material being machined on the outside here. That's already just being profiled out. So I'll just grab that geometry. But I can also control where that boundary sits as well. So I can increase it. I'm not using any sketches at all, just using the native geometry of the SOLIDWORks model. I can access the sketches as well, but in this case, I just want to leave them at the actual edge there. So I can just limit the toolpath to that region here. And I'm going to just for the sake of it, this is quite a big file. It's about 26 inches long here. I'm just going to kind of crank up the step down, and we'll go in with maybe like an inch cutter here as well. As far as the holder goes, it's not very stuck far out, so obviously I'm not going to be able to go down here and cut all the way down here right at the very edge with my allowance. And that's where I wanted to point out some of the other options. So if we have got people, customers on the webinar that are using some 3-axis here, I can use some of these options down here. So I can tell it to go and calculate the minimum tool protrusion that I would need to actually go and program this part. So it's going to go through and calculate what that minimum value is. And then in this case, it's actually just going straight down the wall. So really, it would be clipping the holder as it's running all the way down here, which isn't realistic. So what I can actually do is on that advanced tab, you can see here it's giving me the minimum tool protrusion of 13 inches. Now that's got no chance of happening. So in here, what we could do is we could actually just go in and enable the collision detection with the holder and tell it to go and calculate a toolpath that is somewhat safe, that is stepping away from the outside edges. It will step it in, so it will cut it successfully. So you can see it's actually, as it's working its way down here, it's cutting all the way down into there. And as far as getting access to the other regions in here, basically what I can do is I can go and maybe put in a couple of other setups. So and just maybe use some indexing. So I've got some other planes in here that are inclined over on the other side over here. So if I'm going to go maybe machine from this direction, again, select the surfaces here. Maybe we'll just go and grab this main piece over here. In this case, we just want to do a rough, but I want to take all those settings that we use. I don't want to have to rework all those settings again. I can also just go in here and manually say add, and tell it to copy from a previous operation. So I'm just using the previous operation information. It's gone in and set all the clearances up for me here. It's going to set the same tool, the same steps down, and things like this. It's even gone to the point of copying that contain area for me. So now I could go through and, excuse me. Now I also don't want to go and sit there machining everything again. Half of that material is being bulked out and cleared out of the way already. I can use some of the rest machining, so I can actually tell it to go and calculate what's being left over from the first operation and just go and say, okay, I want to machine what's left over from this using this next operation. And then whilst that's calculating, I can go in and keep working. I don't have to sit there waiting for it to generate. I can just go in and say, choose my other system here, my other plane in here. And you'll see there's actually the warning there with the tool protrusion. When it is less, it gives you a warning in here to tell you there is an issue with it. So we can go in here, go in and put that 3-axis rough again, copying it from the same thing in here as well. In this case, we want the rest machining to be from both of the previous operations. So we're basically using the indexing side of 5-axis, using some of these parameters over here to go and control how we get access to the different areas of the path here, and we can go and obviously set the different indexing angle solutions up and things like that. But now this is going to go and generate based off of the previous 2 roughing operations. So you can see there's obviously a few rapid moves here that I need to go in and fix here. But it's going and just machining the stuff it can get access to down there. Now, once those are actually generated, I can obviously go in and set, do the simulation of it, see what it looks like. I've actually just previously ran this, so I can show you what that is going to look like. Let me just go in and move the coordinate system over here. There we go. So basically, this is what the material would look like after it's all being roughed out using the indexing. But obviously now we want to go and finish it. So I could use a Z level in this case, but it's going to do straight down. So all those undercuts that we looked at, it's not going to cut in there. So we do need to use some 5-axis. So what I'm going to do is basically go through and tell it we want to go and program these. But there's these holes in these surfaces, which if I just generate that toolpath here, if we just go and put in that same container over here, if we go and maybe just change the step down as well, just so we've got some, doesn't take as long to generate here, maybe go in and use that like a 1-inch ball as well. You'll see it's going to basically hit those flats in here. So, which is not really desirable. Maybe those being machined from a separate direction. It's going to go in and start putting toolpath on those areas down here and just treating them straight down, which is not really great. So what we want to do in this case is use some of the SOLIDWORKS tricks. So one of the tools I really like is on the surfaces toolbar. You can just right-click here and enable it. And this is again in the standard package of SOLIDWORKS. You can use the offset surface tool, and maybe you're using this for something like, I don't know, leaving a certain material all the way around the pot. You can use an offset here, and it's going to offset the surface inwards by a certain amount. In this case, I just want to go copy that geometry. Create a nice clean-looking core. I'll ignore that for the moment. I've got this copy of the geometry here that's exactly the same shape. It's linked to the model because it's been driven off of the surfaces, but it's still got those holes in it. Now what I can do to avoid that is I can actually just click on one of the edges here, and I just use the delete key on the keyboard, and it uses this tool called delete hole. If I use delete feature right now, it's going to delete the surface away. It deletes the surface, the feature from the SOLIDWORKS history. And here, the delete hole is actually going to try and fill that gap in and use the native geometry. So I don't have to patch any holes up to stop toolpath going in there. I can just click on it and hit delete. Another example of a similar type of tool is, say for instance, we had a lot of holes or something in the side of this thing. We had a few holes down here, and we didn't want to have to go and deal with those. I just want to remove this piece, this piece, this piece, this piece, for instance. Another option that you've got, rather than using delete hole, is you can use the untrim surface. So if you click on the surface and hit untrim, there's a really nice option called internal edges here, which will actually go in and fill those holes in for you, and basically take it back to a normal surface. So those two are some really nice options if you are working with geometry where there is lots of holes in it and you don't want the toolpath to go into those particular areas because they're going to be machined at a later date. And like I say, these are some of the tools that it's nice to have the CAM and the CAD right next to each other using the same interface. And then I can basically go and program this particular surface only. So I just go in and say, hey, these are the surfaces I want to program. I can go and select the surface body over here to tell it that's what I want to machine. And in this case, I've got a 5-axis mold strategy that I've created here that I've just saved out. I can use that to go in and grab all the tools. The only thing I would need to do is maybe go and select some of the pattern geometry. Let's just bring back the main tool there. In this case, I'm using a flow line, and I'm going to grab the upper surface over here to drive it towards the bottom. So we'll use this one for the upper, and then I'm just going to go and grab another one, this one, to drive it to the bottom of the geometry here. So in this case, we're using 5-axis, and in this case, we're using this tilted with fixed angle to axis. So it's really just going like a regular 3-axis toolpath. The difference in here, though, is I'm using gouge check as well to tilt the tool away. So as soon as it comes down the wall and it starts getting close to where these regions here and these clearances, it's going to actually start tilting the tool away automatically and get into those undercuts. It's going to go and cut those undercuts for me. So again, I've set a smaller step over on this one just to make it generate a little faster. Obviously, it's a 20 by 20 inch high pot. It's quite a big one. But you can use these options here for 5-axis. Another option you actually have got as well for 5-axis, if it is straight walled, there's no undercuts, but it is a deep cavity like this. There's also this option in the same area that we looked at before. When you enable the holder clearance, you can actually convert it to 5-axis as well, and then it will basically tilt the holder in. But if you have got undercuts, you would have to use the other strategy. These are available basically when you've got your 5-axis license as well. So now basically it's just still generating the toolpath here. Maybe we'll just switch back to the PowerPoint, and I can always show you right at the very end there on what it looks like. That was basically what I wanted to cover today. Thank you very much for attending. I'll show that final result at the end once it's finished. But just to give you guys an idea of a few locations where you can get some more information, basically go to the web page. You can go up to the events tab at the top. This is basically where you can go and look at the different webinars. We also have a 3D solution spotlight. Every month we focus on one of the products and give you a series of webinars based on those as well. You can look at different seminars and events that we're holding, night schools. This is where you can access the support. And the blog article is also a really fun one to go to. We try and create interesting content up there to basically to go and give you guys some cool stuff to read. So, and it's on all sorts of different areas of the software, but kind of more related to some of the stuff that we're interested in. So one of my colleagues out of the Calgary office is a huge road biker, so he did some simulation analysis on like a carbon frame. We've got some CAM ones in here as well, looking at sheet metal. So always take a look at this blog article, some cool stuff on how a helicopter downdraft and things like that. So these are always good to go in and check out as well. So there's the support site here where you can go and log in and access the knowledge base of different files. There's a lot of stuff in there as well. But also check out the blog article there as well. So there's the finished toolpath basically in here for that multi-axis, and you can see as it goes through and starts programming this, it'll actually tilt the tool inwards away from the holder and away from the flute and things like that. So by the time you get further down, it's automatically doing the tilting for you. So that's how you can go in and get your undercuts, and you can see here it's actually going and correctly undercutting the toolpath here. One other option that is really nice, actually, just as a sideline here, and is good for particularly 5-axis, is machine simulation. So particularly when you're simulating those types of parts here, basically we can go in and select the actual post that we're going to use to run this on the machine. So in this case, I'm going to use one of those new Haas UMC 750s. Should be in here. And then basically right in where the machine here is, I can go and define what machine I'm going to run. And then I can actually post code out that I'm going to look and run on the machine and verify what that machine is doing, so I can play through it. It's going to output the code right now as if I'm posting the code. And then basically it will load up the full machine simulation and show you the machine in there, and you can simulate the movements. So that's really good and handy for anytime you're doing any 5-axis. You can bring the code up, tells you what any messages, any errors, and things like that. And you can play through the actual simulation and see what the machine is going to be doing. So this is another good option to have if you are doing any 5-axis work. So that's just a little side note I thought I'd throw in there. So with that, I'd like to thank you for attending. That's just a little bit out of the blogs, and I will be here for some questions. So if you've got any questions, there should be a questions panel in your GoToWebinar. If you want to ask any questions, just by all means fire away, and we'll be here for a little while just answering those. But if not, thank you very much for attending, and enjoy the rest of your day.